Hello everyone, welcome to my channel CISC Topper Classes. Today we are going to discuss exercise 13.1 question number 18 to 23 of M.L.aggarwal class 9 mathematics. So let us start solving this exercise here in this video. If you like this video, please like, share and subscribe my channel. Now let us solve question number 8. In a parallelogram ABCD, the bisector of angle A meets DC in E and AB is equal to 2AD. Then prove that BE bisects angle B. Firstly, here we can say in the first part to prove BE bisects angle B, we have angle 2 and angle 3 as alternate angles. So these angles will be equal. And from there only, firstly we'll write angle 2 is equal to angle 3 and angle 1 is equal to angle 2 because AE is the bisector of angle A. Here this AE bisects angle A and these are alternate angles. So simply from these two information, we can write here that angle 1 is equal to angle 3. And if angle 1 is equal to angle 3, opposite sides of equal angle are equal. So we can simply write opposite sides of equal angles are equal. So here we can write as angle 1 is equal to angle 3. We can write this DE is equal to AD. So here it will be AD is equal to DE. And the second thing here is, again we have, here we can write that this AB is equal to 2AD written. So AB by 2 is equal to AD. And from here we can write AD is equal to DE and AB is equal to DC here. So DC by 2. Similarly, we can write here BC is equal to AD and AD here is equal to DE, means BC is equal to DE, and as here E is the midpoint, as we have proved here that DC by 2 is equal to DE, means E is the midpoint here. We can simply write here BC is equal to here this is DE, EC here. If BC is equal to EC, then we can simply say that angle 5 is equal to angle C. Opposite sides which are equal, opposite angles are also equal. So here we can see that angle 5 is equal to angle 6. And if angle 5 is equal to angle 6 here, we have angle 5 and angle 4 as alternate angles. So angle 5 is equal to angle 4 also because these are alternate angles here. And from that only we can say that this angle 5 is angle 6 is equal to angle 4 from here. As angle 6 is equal to angle 4, we can simply say that BE also bisects here angle B. Hence from here we can conclude that BE bisects angle B. This is only we have to prove, hence proved from here. Solve the second part here. Here angle AEB is a right angle. Simply from here we can say that angle, firstly we will take the adjacent angles in this diagram as angle A and angle B are adjacent angles, means sum of these angles is equal to 180 degree, and if we add the half of the angle, means these two lines bisect the angle A and angle B, means angle 2 plus angle 4 will be 90 degree and angle 1 plus angle 6 is also 90 degree. So simply from here we can write as angle 2 plus angle 4 is equal to 90 degree, because here we can prove also the, firstly we have angle A plus angle B are adjacent angles of a parallelogram, that because of that their sum is 180 degree. Again, because AE bisects the angle A, so half of angle A plus half of angle B is equal to 90 degree, and here only we can put angle 2 and 4 because half of angle A is angle 2 only in this diagram. Angle 2 plus angle 4 is equal to 90 degree. Now we can take the triangle here AEB to prove that angle AEB is equal to 90 degree here. So simply we can take in triangle AEB, we have angle EAB plus angle AEB plus angle EBA, which is equal to 180 degree. Simply we can write the angle here. So angle EAB plus EBA, we can write it as angle 2 plus angle 4 and plus angle AEB. So as the sum of angle 2 plus angle 4 is 90 degree, we can write here 90 degree plus angle AEB equal to 180 degree. Then from here we can prove angle AEB is equal to 180 degree minus 90 degree, which is 90 degree only. Hence proved from here that the angle of AEB is 90 degree. So hence proved. Let us solve your 19th question. ABCD is a parallelogram. Bisectors of angle A and B meet at E here, lies on DC. Then we have to prove that AB is equal to 2AD. So to prove this, firstly we will take the angles here. So here angle 1 is equal to angle 5. Angle 1 is equal to angle 5 because these are alternate angles. And angle 2 is equal to angle 1 because AE is the bisector of angle A. So here also angle 1 is equal to angle 2. From that we can write angle 2 is equal to angle 5. So angle, because AE is the bisector of angle A. And here as the two angles are of a triangle, two angles are equal means the two opposite sides will also be equal. Two angles are equal. Two angles here are equal. It means that two opposite sides are equal. So simply we can write here as angle 2 is equal to angle 5, AD is equal to DE. Now this is the first thing let, and again we can write in the same case as in triangle the BCE. So again we have angle 3 is equal to angle 6 because these are alternate angles. And then angle 3 is equal to angle 4 because BE is the bisector of angle B. Now as angle 4 is equal to angle 6, from that again we have two angles as equal of a triangle means two opposite sides are equal. From there only we can write here. This is the thing. Now we can write CE is equal to BC here. Let it put it the second here. Now and as AD is equal to BC because these are opposite sides of a parallelogram. So we can simply write it as if AD is equal to BC, then CE is equal to DE. Means AD is equal to DE, DE is equal to CE, and that is equal to BC here. So this is the thing here. Now simply from here we can write that if DE is equal to CE, means E is the midpoint here. Again we have now AB is equal to DC because this is also the opposite side of a parallelogram. So because this is also opposite side of a parallelogram, we can simply write it as if AB is equal to DC, DC is equal to DE plus EC. So here we can write AB is equal to DE plus DC. And here this DC, whole thing we can write it as DE plus EC. So AB is equal to DE plus DC. We can put the value of AD here. So AB is equal to AD and here we have DC. Sorry, this is EC here. So here EC is equal to AD only. So we can write EC again AD and AB is equal to 2AD. And this is only we have to prove in this question. Hence proved from here. So this is only we have to prove. Now let us solve question number 20. ABCD is a square and the diagonals intersect at O. If P is a point on AB such that AO is equal to AP here, and we have to prove that 3 angle POB is equal to angle AOP. Here we can simply say by seeing that if it is a square, angle CAB, this angle CAB is equal to 90 degree, because in a square the angles ABCD are 90 degree. Now we will take the triangle here. In triangle AOP, we will have OAP, angle OAP as CAP. Sorry, it is CAP is equal to 90 degree. We can say angle OAP is equal to 90 degree here given to us. And the second thing which we have to, as the given information is AB, AO is equal to AP. As the two sides are equal, angle opposites are also equal, means angle AOP is equal to angle APO here. Means we can write angle AOP plus angle APO plus angle OAP is equal to 180 degree. We will simply put the value here. This will be 2 angle AOP plus OAP as OAP is 90 degree here, or we can say it is 45 degree, sorry, because the diagonal AC bisects the 90 degree. So here we have angle OAP as 45 degree. So it will be 180 degree minus 45 degree, means angle AOP is equal to 135 degree divided by 2. Again we will take the triangle here as the sum of the angles AOP and POB is equal to 90 degree. So because these two are 90 degree, because the diagonals intersect of a square at right angle, means we can simply write here angle AOP plus angle POB is equal to 90 degree. We will put the value of AOP. This will be 135 degree by 2 plus angle POB equal to 90 degree. Means this will be POB equal to 180 degree minus 135 divided by 2. So it will be 45 degree divided by 2. If we will write here, as this is angle POB which we have to compare, we will multiply it by 3. So multiplying by 3, we will get as 3 angle POB is equal to 135 degree divided by 2. We will compare this part with this AOP, and this is only we have to prove here. So we can simply write that 3 POB here, which we have to prove, 3 POB is equal to angle AOP. So this 3 POB is equal to angle AOP, because this 135 degree by 2 is equal to 135 degree by 2 here. Hence proved from here. This is only we have to prove, and this is the solution of this question 20. Let us solve question number 21. ABCD is a square. EFGH are points on the side AB, BC, CD and DA respectively, such that AE is equal to BF, this is equal to CG and this is equal to DH. So simply here we can write AE is equal to BF, this is equal to, it is BF, and this is equal to CG, this is equal to DH. So from this part only we can write that this EB is equal to CF, EB is equal to CF, and this is equal to DG, and this is equal to HA. So simply here we can take the triangle in triangle AHE and triangle BEF. We can write here AE is equal to BF. So here the first part is AE is equal to BF. This is given to us. Again we have HA is equal to EB. So HA is equal to EB, and the angle A and angle B is equal because these both are each of 90 degree. So from that we can write triangle AHE is congruent to triangle BEF by side angle side rule of congruency. So from this only we can prove here from this congruency, and by CPCT we can write that angle 4 is equal to angle 2. Here this angle 4 is equal to angle 2 and HE is equal to EF. By CPCT we can write, as we have, because angle A is equal to 90 degree, so if it is equal to 90 degree, H and E means angle 4 plus angle 1 is equal to 90 degree. So angle 4 plus angle 1 is equal to 90 degree, as angle 2 is equal to angle 4. We can write angle 2 plus angle 1 is equal to 90 degree, and hence from here only we can write angle HEF is equal to 90 degree, and from this part, and HE is equal to EF here, from this part we can write, hence proved that EFGH, sorry, this is EFGH is a square, because the angle of HEF is equal to 90 degree. From one angle only we can prove that EFG is a square, hence proved. This is only we have to prove in the 21st question. Now let us solve question number 22, first part. In figure given below, ABCD and ABEF are parallelograms, then prove that CDEF is a parallelogram. So simply here, as DC is parallel to AB, because this ABCD is a parallelogram, opposite sides will be equal. So AB is equal to DC, and again, as ABEF is also a parallelogram and AB is parallel to EF, if AB is parallel to EF means AB is equal to EF. Again we have to prove that CDEF is a parallelogram. So in CDEF, as CD is parallel to FE, CD is parallel to FE, so CD is equal to EF, and from there only we have proved the first part, that CDEF is a parallelogram, because opposite sides of a parallelogram are equal and parallel. Now, as we have proved the first part here, we can prove the second part simply, as FD is equal to EC. And in a parallelogram, as we have proved that CD is a parallelogram, FD is equal to EC here. So this is only we have to prove, and by a parallelogram we can prove this part. Now the third part which we have to prove is triangle AFD is congruent to triangle BEC. So here we have proved that FD, first part is FD is equal to EC. The second thing which we have proved that opposite sides of a parallelogram equal. In ABEF we have AF is equal to BE, because these are the opposite sides of a parallelogram. Second part, opposite sides of a parallelogram. Now the third thing, which is AD is equal to CB, because this is also a parallelogram and the opposite side of a parallelogram are equal, means AD is equal to BC. This is only here also, opposite sides of a parallelogram are equal. So we can simply write here triangle AFD is congruent to triangle BEC by side, side and side rule of congruency. So this is we have to prove in this question, hence proved from here. Hence proved. Now let us solve question number 22. In the figure given below, ABCD is a parallelogram, ADEF and AGHB are two squares, then prove that FG is equal to AC here. So firstly we have, as the sum of all the angles surrounding of a point is 360 degree, we can write angle FAG plus angle FAD plus angle BAD plus angle GAB is equal to 360 degree, and angle of FAD plus angle of GAB is 90 degree. So we can write angle of FAG plus angle of GA, or we can write BAD. BAD is plus 90 degree here, FAD, because it is a square, and again this is also 90 degree, which will be equal to 360 degree, means FAG plus angle BAD is equal to 360 degree minus 180 degree, and this will be again 180 degree. Now we can write angle FAG is equal to 180 degree minus angle BAD. Simply, now in the parallelogram ABCD, we can write the sum of two adjacent angles as 180 degree, means here. Now in parallelogram ABCD, we can write here angle BAD plus angle ABC is equal to 180 degree, as the adjacent angle sum in a parallelogram is 180 degree, means angle ABC is equal to 180 degree minus angle BAD. And these both are as the same thing only. We can write from here angle FAG is equal to angle ABC here. So hence we can write angle FAG. So angle FAG is equal to angle ABC from here. Now as DA is the same thing, we will take the triangle here as ABC and this as FAG. So simply we can write here that if AB is equal to here, because this is the with same base the square as of AG. So AB is equal to AG here. From here we can write AB is equal to AG, and again FA is the square here and DA with same base as that of this parallelogram. So FA is equal to DA, and as FA is equal to DA in a parallelogram, the opposite sides are also equal, means DA is equal to CB. So here we can write FA is equal to DA and this is equal to CB, and AB is equal to AG. Putting it as first, second and third points in triangle ABC and triangle FAG. From here only we can prove that triangle ABC is congruent to triangle FAG, hence proved. This is the main thing which we have to prove in this question, that if this is proved, we can simply say that the side here FG is equal to AC. So this is only we have to prove FG is equal to AC by CPCT in this question. Hence proved from here. So this is only we have to prove in this question. Now let us solve 23 question. ABCD is a rhombus in which angle A is equal to 60 degree. Then find the ratio of AC ratio BD. So here AB is equal to BD because it is a rhombus, and triangle ABD is an equilateral triangle. So simply we can write it as here, if AOB is equal to angle AOB is equal to 90 degree, we can write here AB square is equal to OA square plus OB square. So here we can put AB as A, and again this whole thing as A, OA and OB. So writing it as AB square as A square, as we will put here AB as A, we will get here OB as A by 2. So simply A square is equal to OA square plus A square divided by 4, means A square minus A square by 4 is equal to OA square. Here this will be 3A square by 4 equal to OA square. We will take the under root here. It will be 3A divided by 2 as the value of OA here. Now simply we have to find the value of AC ratio BD. So here BD we can write it as double of A only, because A by 2 double is A only, means BD is equal to A, and here AC is here, if OA is equal to under root 3A by 2, AC is equal to under root 3 A only, because we will multiply it with 2. So AC ratio BD, from here only we can write under root 3A divided by A will be cancelled out, means under root 3 ratio 1 is the final answer which we have to prove. Thank you for watching my video. If you like this video, please like, share and subscribe my channel.